Hi, welcome to Advanced Physical Science. This is 3.3b, Momentum and Impulse. So momentum and impulse, we know that momentum is mass times velocity. We also know that impulse is force times time. But what happens if a change in the velocity happens? That means the momentum changes and acceleration, either positive or negative, would occur. But we know for acceleration to occur, a force has to be applied. And if a given force is applied over a longer period of time, more acceleration occurs. Impulse is equal to a change in momentum. J is equal to delta P. So the impulse momentum theorem says that impulse is equal to the change in momentum. This theorem reveals some interesting relationships as the inverse relationship between force and time. So on your formula sheet, you're going to want to put J is equal to delta P, which means force times time is equal to mass times a change in velocity. It also means that force is mass times that change in velocity divided by time. Time is mass times the change in velocity divided by force. Mass is force times time divided by the change in velocity, and the change in velocity is force times time divided by mass. J remembers impulse in Newton seconds, abbreviated NS. P is momentum in kilogram meters per second, kilogram m/s. F is force in newtons. T is time in seconds. M is mass in kilograms. V is velocity in meters per second. Remember that the delta, the triangle, does mean change in. So here's your impulse relationship. If you have the same truck moving at the same velocity, is it going to experience a greater force by hitting a haystack or by hitting a wall? Well, notice that when it hits the haystack, it increases the amount of time and therefore decreases the force. But when it hits a wall, it increases the force, decreasing the amount of time. Impulse momentum relationships, remember that force and mass could be held constant. For the same force, why is the speed of cannonball greater when it's shot from a longer cannon barrel? Since time is directly related to velocity, when the force and mass are constant, the longer the cannonball is in the barrel, the greater the velocity. You could also say that force acts over a larger displacement, thus more work is done, and we'll get to that in Unit 4. So there are several cases. One is increasing the momentum. The impulse of a bat decreases the ball and accelerates it in the opposite direction very quickly. When you have a change of direction, you increase the momentum. A karate chop does something similar. It increases the amount of force, which increases the momentum, decreasing the time. Hitting the bricks with a sharp karate blow very quickly maximizes the force exerted on the bricks and helps them to break. Then you could have the case of decreasing the momentum. It takes an impulse to change momentum, and remember that impulse is force times time. So if you want to stop something's motion, you can apply a lot of force over a short time, or you can apply a little force over a long time. Remember that if you apply a lot of force, things tend to break. Think again of the truck going through a haystack, people jumping down onto a trampoline, or even rockets. A lot of force, longer time. This is what airbags do. An airbag extends the time over which the impulse is exerted and therefore decreasing the force. You could also decrease the momentum over a short time. If a boxer moves away from a punch, he extends the time and decreases the force while stopping the punch. If he moves toward the punch, he decreases the time and increases the force. Which would you rather have? So here's an example of the kind of problem you're going to do in class. Jennifer, who has a mass of 50 kilograms, is riding at 35 meters per second in a little red sports car when she suddenly slams on the brakes to avoid hitting a deer. She strikes the airbag that brings her body to a stop in 0.5 seconds. What average force does the seatbelt exert on her? Well, this is a TÜV chart, because in this problem, you're given the mass in kilograms of 50, velocity of 35, and then stopping of 0 to get a change in velocity of 35, a time of 0.5 seconds, and you're trying to find the force. So force is mass times the change in velocity divided by time. 50 times 35 divided by 0.5 gives a force from the seatbelt of 3,500 newtons. Thanks for watching.